Okay. Okay, so hey everyone, welcome back to another stream. Last time we did lots of miscellaneous things, but in particular we wrote some tests for a QOI parser that we're using. In particular, for a couple of images. In particular, for the images in QOI test here, for the images, for these ones, for this really simple one here, which are 4 red pixels and a blue, we basically made some concrete tests to make sure that a parser that we wrote from scratch that decodes one of these files creates an array of bytes. For instance, if I open up this file in hex, rb.qoi, it's currently this thing. If I turn on hexel mode, this is what it looks like here. These are the bytes representing this file, and we want to make sure that the decoder that we wrote is actually working. The whole reason why I started this was that several streams ago, when I tried working with Raylib functions to import a font file, things were really frustrating, it wasn't working, and so I figured this was a great time to do stuff manually. So I just want to do one more test today, and then we'll transfer to the font part. Okay, so there was another image. There's another image we created. This one here, and I just want to write a test for this one. And then if this one's working, we truly should be good to go. So it should be possible to kind of copy past all of this stuff. So let me try and do we'll call this a 3x4 decoder, and let us replace this. Replace all of the RBX with 3x4. We want this to be 12. We want to actually import this 3x4 image. And what do we get? So from memory, let's see what these actual pixels are. How do I do it again? I have to do like color picker in, it's not power tools, it's power toys, that's right. Okay, if that actually works. Where is it? This one. Load, please. Okay. So yeah, red, empty, red, not empty, that thing, white, green, gray, red, gray. Okay. Okay, yeah, so the first three were red, similar to here, and then we get the empty pixel. Why is this not aligned? Then it was red again. I'm not gonna lie, this alignment is just slightly annoying me. Okay. red, 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 blank, and then it's red, gray, white, green. So red, gray, I'll just do this for the moment. White, which is 255, 255, 255, 255. Green. And then green, gray, red, gray. So yep, green. And gray was 136 from memory. We can check this. Yeah, so in hex, 66 is 102. Oh, they're a bit different. Red, gray. That is red, and then we just want another gray. Red. Yeah, green, gray, red, gray. Oh, cool. Someone is raiding, apparently. Yeah, this is a cool raid. Hopefully, whoever's watching will be interested. Okay, so let's check. Red, 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 blank, red. The unknown one we need to fill in. Yeah, Z grade to Z grade. This is pretty cool. I'm happy. Hopefully we can see more of it. Okay. So this is meant to be 13, 16, 14. 13, 16, 14. Then it's white, and then it's meant to be green. Oops, this is the third row. Okay, that's the third row. Green, green, this gray, red, and then the gray. Okay. Okay, let's give this test a go. Zig test qi.zig. Fail. Why? Hello rating people. Currently, just to provide context for what I'm doing, I'm just working on from scratch a QI image parser. A couple of streams ago, I did all of the parsing stuff from the QI specification. This is the quite okay image format. Unlike PNG files or JPEG files, where the specification takes like a month to read because it's so complicated. This one is just a single page PDF. You can read it in an hour. That's what I did. More importantly, you can write code to decode it within a couple of hours, which is what I did. And so before I start using this in a game project which I'm working on, which is to build a very simple 2x2 Sudoku app, which will later be transformed into something else. The app looks like this at this stage. I need to have in some way of just like reading in QRFIs manually, so using the whole Zig from scratch mentality, this is what I'm doing. But before I just do that, I'm just writing a couple of tests using some simple images we manually generated. Music image viewer. In particular, I am currently writing a test to just make sure that the parser, when it processes these pixels, actually gives us the pixels we want. Okay, but currently we're having some slight compilation issues, but we'll get over these quickly. Okay, so, okay, what's this? Line 14. What's going on? Content number literal. Oh, how? Okay, this is okay. Let's call this 3 by 4 image. And then down in our tests here, let's just replace all versions of 3 by 4 image with that other version. 3 by 4 image. Okay. No, okay. I didn't quite. Let's do something even better. Let's just replace 3 by 4 with 3 by 4. Yep. And this one we do need. Okay, better. What now? Expected semicolon after declaration. Great, all 3 tests passed. Hurrah. Okay, we're now ready to move on to the main part of this stream, which is now using this importer to do some bitmaps. Okay, so let's go to this to-do list. Lots of stuff to implement, but the stuff we'll do today is the bitmap. Okay, before we actually do the bitmap importing, we need to generate some bitmaps. So several streams ago, I found that on Windows there's this bitmap font generator app that enables creation and exporting of simple bitmaps from really any given font type. So for example, when the options are set appropriately, for instance, let's make a PNG image 500 by 500. You get the given fonts here. This is a default Windows font that I want to try just using this in the Sudoku app to begin with. It doesn't look too bad to me. So yeah, this is a size of 10 pixels. So if we make the texture have a height, a width of, let's say 50 and a height of 20. This looks alright to me. We now want to export this. And we're going to convert it to a QOI file, but before we do that, I want to make sure that it's being exported in a simple way. Okay, so if we do, say, like white text on black, then this will give us, the RGB values for one of these pixels will be 255. For the other ones, they'll be 0. I reckon this is a pretty simple method to work with. So we want, say, white text on black. Okay. So I haven't used this tool extensively, but it seems to be simple. Okay, I think this is how we save it. So what was this font? This was like the 8514, which is just this one here. Okay. So we want to save this as, no, we want to export this one. So let's, let's keep this up on the screen. So it's called 8514 test. Save. Should be this one here. So if we do the zig image viewer 85114 test 0. This image viewer is in extreme alpha, by the way, and is also written in zig. But I don't see it being loaded anywhere. Let's try another. Okay, that seems to be there, but not exactly white on black. I'm confused. This is not what we do. In either case, we can. I'm still not comfortable moving forwards until I actually get something that looks like it's going to work. Why don't we try some different options? What if we did do, say like black text on white? Let's try this one. Save this as similar thing. 8514 test 3. Nope. This is not what I. Actually, that's not. Yeah, this isn't what I wanted. Okay, let us just export this to a QOI and import it anyway, and we'll just be able to look at the pixels directly, because this could be a problem with the image viewers. Until we actually examine the hex, who knows? Okay. So yeah, let's instead move this one to say 84114, call this 3, convert this to a QRI file, and now let's try importing it. So let's move it to our tests, and then within the tests, let's try it here. 85143 QRI, and let's call this bitmap 1. Okay, and then in our actual main code, we just want to be doing something similar to these, but with the bitmap 1. Okay. So let's say bitmap1 header is comp-time header parser bitmap1. The width is just going to be the header. Likewise here. I want those things, and then finally we want the bitmap one. Ooh, yep, this looks like it should be fine. Okay. Zig run qi.test. .qi.zig. Did we not call this bitmap one? Okay. Easy fix. Okay, great. Okay, that did it, but we need to actually print it out. So debug print the pixels. Bitmap 1 pixels. Okay. Yeah, I'm not seeing any variation in all of these. All of these look white. Okay. So yeah, something really is going wrong with exporting using this stuff. Let's play around with some more options and see if one of these eventually works. Because this app did seem pretty robust. It seemed as though it had been updated recently. And just for reference, this was PM font 64. So it was this thing here. This program will allow you to generate bitmap fonts from types. And somewhere on here is first released in 2004, but continued to be updated until like last year. So this year, I don't know the year. So it should be, there's no reason why it should not work. If anyone in chat has experience with this, please let me know. Please let me know which of these preset options I should be choosing in order to get something that looks like this. Because that's all I want. I just want this thing as a PNG, can then convert it to a QOI file, and then it's stable for a very long time. The QOI specification is simple enough that anyone who uses any decent systems programming language can write this specification in less than a day. So okay, so we tried this white text on black and it failed, this black text on white and it failed. So why don't we try maybe just like black text with alpha, or maybe just white text with alpha. We'll try this one first. Okay. Save. I'll start calling these test4. Let's try and view these again. What is it? Zig image viewer test4 0.png. The Zig image viewer isn't always working, but it's okay. It is in pre-alpha. Okay, this worked. Great. We are in business. Magic K test4. So this is 8514 bitmap.qai. Let's copy this this bitmap to our temporary testing area, and then let's run the same zig test. Zig run qi.zig. Great. This is great. I can see white pixels here. I can see empty ones. Great. So yeah, so it looks like the program has automatically converted whatever was the alpha to black pixels and whatever was that to white. Cool. Okay, now that's working, let's try and actually kind of get this to a texture and render this in the app. Okay, so go to main. Okay, so this is where like chat could be very helpful when it comes to guiding stuff. The previous app I made, everything was in a single zig file. It's just in this one. But now I have two files. Question, how do I make it so that when I do git zig run, I can... How do I just call the QOI files in this main file? I'm not sure how to do that in Zig. Do I possibly have to change this build file so that I say like instead of just looking at main at path.zig, also look at path and qoi.zig? If anyone in chat knows, please let me know. Yeah. Otherwise, I would just need to look up documentation or some kind of examples. Yeah, are you there? Two-step? Do you know what to do in this case? Another thing I can do is just browse some other people's projects in Zig and just look at how they handled all of the imports of different stuff. So yeah, are the files in the same directory? Yes. So if I clear this, actually, I'm going to save what we've done so far to GitHub. But yeah, the project at this stage is just two files, main.zig and qoi.zig. Those are the only ones I currently care about. Get out here. Okay, so yeah, we added some more tests to qoi.zig, and now I want to add the imported image. So this was with the 8514 bitmap.qoi. Just to check this is, yeah, that's the one we wanted. Okay, so now let's do added another QOI decoder concrete test for the 3x4 image and created a bitmap to a 1234 bitmap to use. And yeah, all of the code, by the way, for anyone watching, for all of my projects is always on GitHub. We're on the we're on this branch. Where are we? I just want to do push with tracking to GitHub storage, the main branch. In particular, if you go to my GitHub page, github.com loaded, you can see the projects that we've done so far. Last project I did was making a very simple quiz game to help me memorize the patterns and the names of a bunch of butterflies. If you haven't seen this before, if I do a zig build run right now, this again, we did all of this from scratch. You can see all of the code. Basically, the entire code of the app is just this single file. It's very simple, less than 600 lines. And then the app itself is like, this is a morning cloak, painted lady, leaf skipperling. Yeah, we just made this simple buttons, a bit of text rendering, a bit of images, and so likewise for the current project, the changes I just pushed. You can see that the bitmap file is here, although apparently GitHub can't render QOI files just yet. All of the code, etc. So yeah, just putting that out there in case anyone is interested in how accessible this stuff is. Okay, so yeah, so two-step is saying, so just import const x equals import x.sig. Oh, great. Okay, so I can just say QOI equals import QOI.zig. Excellent. Okay, in that case, let me let's just call the relevant code we need in this main one. So in particular, we go to the QOI.zig. We want to now move the bitmap import to here. I just call it bitmap. It doesn't actually need to be bitmap 1. And then in the part where we actually did stuff with it, I'm just going to copy this directly over. Before the main game loop, let's just do a debug and print all of this here. I can remove the number 1 from all of this. Okay, let's check if this works. 4x4, zig build. It should just be zig build run. Okay. Why does it not know comptine header parser even though that is in here? Oh, because I haven't made it. Oh, I did make this public though. Yeah. Any idea two-step what's going on with this? Oh, okay. X.foo. Okay, I'm not calling it in the correct way. Okay. So I should be calling this then as QOI dot blah. Okay. So if we go to main loop. So if down here I say QOI dot parser, QOI dot QOI to pixels. Okay, it doesn't know what pixel is either. Okay, for a similar reason. So if I do constant pixel equals QOI dot pixel. Okay, doesn't know dprint, that's also fine. But we can just, let's just insert that in here. Pixel is not marked pub. Okay. Or I can just literally just copy that pixel is just 4 bytes. Oh, but now it's going to get confused. Oh, what did it work? Okay. Great. This is now working. Thanks two-step. as usual for the help. Okay, so now let's actually get stuff drawing. Let's import all of these ones and zeros into some of these squares. Okay, so to do this, okay, I mean a couple of different minds how to do this. I think with this app, if we were to draw every single pixel in this bitmap as a separate rectangle, we could do some fun like shading stuff, or we could create some fun effects. I think in this case, it would be like computationally feasible to do this because these bitmaps are just like 10 bytes height, roughly speaking, and there's not going to be that many numbers drawn, and so we won't actually be drawing too many rectangles if we were to do it in this way. Alternatively, we could play with Raylib and just figure out using this Raylib cheat sheet how to get textures in. I am tempted at the moment just to convert all of this to a single array of booleans, where a 0 represents don't draw any rectangle and a 1 represents draw a rectangle, and then render the bitmap that way. This would be the easiest to implement, I think, and this would bypass having to figure out converting this into a texture. So I'm going to do that. We'll do this easy option first. If we run into problems, we'll deal with it then. Okay. So back to the main loop. Now we've got our bitmap pixels. Debug. Let's just create a boolean of this stuff. So we can say, I'm just realizing I should be slightly wary of calling this width and height in this really general app. Let me change that now. So let's change width. Let's change width to bitmap width. And likewise, let's change height to bitmap height. Okay, so now I want to say bitmap bools is going to be something of type bitmap width times bitmap height. Literally, we'll make it a bool. And then all we want to do is for each of these pixels, read the very first character, and then we just want to cast in such a way that zeros get sent to false and 255 gets sent to true. So why didn't I say then for in the bitmap pixels, for every pixel in here, we want to keep track of indices. Set the ith one of these to what is a nice way of doing this? Can I do bool from okay, I can literally just do bool. I don't need this at all. I can just say is the very first pixel value equal to 255? If it is, great. Okay, so now down here, let's print out the bitmap bools. What's this? Variables must be initialized. Well, we're going to fill it up with stuff. What? No field named image bitmap width in this. Oh, oops, I shouldn't have added that in. Okay. Yeah, this seems to, I see true and false, so this seems to be working. So now let's draw rectangles using this then. So, in this main game loop, let's jump to the render. Begin drawing and drawing, da-di-da-di-da. Okay, when we're rendering the puzzles, let's draw the bitmap at the very end. So draw the pixels of the bitmap by drawing a rectangle for each true the true value in the bitmap. Okay. So, okay, we're gonna have to know okay, this bitmap comes with like a width and, yeah, comes with a width and height, obviously. So we now need to just scale those appropriately when we're drawing all of these. Later on in later streams, you know, we'll divide this up. It won't be too hard. We'll make all of this more robust. But at the moment, I just want to draw stuff on the screen. Then we'll figure out the smaller details later. So using what do we we want to know this height. So we could say bitmap screen width is going to equal what? How should we scale this appropriately? Why don't we make this screen width like half of the I'll call it on here. We'll make this half of the usual screen width, and then we'll define everything else relative to it. So now we want to define the screen height to be this screen width times the ratio of the height divided by the width. Is that the order? I think so. Bitmap height over bitmap width. Let's just think about the types of these things so we're not doing anything silly. So this is a U34, but I want to treat it as a float, and this is likewise a U64 that I want to treat as a float. So this thing here is a float. Okay, so let's then do, what's the command? If I do as F64 bitmap height divided by F64 bitmap width, will this compile? No, but for a different reason. It's saying I do, it's saying it, oh, okay. if we're running this at comp time, we may as well move all of this to a global scope anyway. The only thing that actually needs to happen at runtime is this part here. Let's move all of this to global scope. In fact, I can move it down here. Load bitmap at make space to decode the bitmap at comp time. So embed this file, run it, get these widths, make space for it. And now we have space for it, and now that these are actually global, hopefully this should compile now. No, unused local constant 288. Okay, yeah, we're not yet printing it clearly. Let's just draw a rectangle with these things. Draw centered rect at the center of the screen. Yes, 0.5 times screen width. 0.5 times screen height. Which I think I'm referring to it like that. And then for the height, screen width, bitmap, screen height. And then in terms of the color, let's make this just a debug color at the moment. No. Wants F32, found F64. Okay. Let's convert these over then. Great, okay. That purple box there looks like the dimensions of looks like the dimensions of the image. Right. Documents 4x4. Bit 85. I mean, it looks like the dimensions of that, so it seems to be working. Okay, so now let's actually draw the individual pixels. So, let's go up again. Should comment this as well. Load at runtime the run might runtime the bitmap. Okay. And convert to an array of. Okay. Yeah, this one is just a debug. Okay, so now we want to say, as we go through this array, we want to figure out the center of. We basically want to figure out the center of each pixel that we're drawing. So, what's the best way to do this? So let's just have a for loop then, where we're going from 0 to the bitmap width, since the bitmap width is just a number in pixels. And then let's capture this as, say, x, bx. And then likewise, we want to go to the bitmap height, capture this as, say, pixel y. Now we need to determine the position, pixel position, and this is going to be, let's define this relative to the very top left pixel. So we can do top left pixel is equal to let's see, what are we going to do? We first need to define a size for the pixels, actually. So why didn't I say like pixel square size, and let's make this like 0.01 times the screen width. Okay. Now we have that, we can locate the top left pixel. So this will be, say, the center of the screen. So let's start off with the screen, the center of the screen width. We want to subtract from this let's say half of the bitmap screen width. We're gonna have to make this full screen. Bitmap screen width. That's now like the left position. Likewise, we want to do the height. So the height is going to be half of the screen height, but now plus it's still minus, because in Raylib or in most places the top left corner is the origin. We want to take off the height. So this is like the top left pixel, but it's like the top left corner of the top left pixel. So top left pixel corner is this, and then the actual top left pixel center that we want is going to be this corner plus half of the pixel square size. So yeah, back to 0.5 times pixel square size. Likewise here. Okay. Finally calculated this, so now we can calculate the position of an arbitrary pixel. And so this is now going to be the top left pixel center plus an offset, and this offset is just going to be the px, which we might need to convert actually. Let's make this an F32 times the pixel square size. Okay. I kind of want to change the name a bit, but it's not too horrendous yet. And then likewise, we want to just add in the y. And what are we doing? We've got the position, and then we simply want to draw it only if it's actually a Boolean. Yes, there's going to be some like, we can do this in a way that doesn't involve a branch, but who cares? At the moment, let's just do a branch. We'll mark it later that probably should get rid of the if. So let's simply say now if using this one, the bitmap rules, if a bitmap rules, if the I value is going to be it should be px times px. No. Py times bitmap width plus px. If this is true, since it's a boolean, let's draw the rectangle. Draw centered rect at the pixel pos and the height of everything. Pixel square size. And let's make this, let's just make it debug again. Okay. Get rid of all of this. Let's try building this. Fail. Why? Expected comma after initialize. Oh yeah. Oops. What was this? 291. So here, it should be times. Here. Expected comma after initializer. 291. Did I make the same mistake again? Alright, I need to make everything full screen since stuff is not getting wrapped. Okay, so this is still failing on 291, but I thought we... Okay. Undeclared identifier screen height. Okay. I think I just called this the screen hit because it's like a really big one that gets updated. Okay. But use of undeclared identifier bitmap rules 297. Was this not? Is this not a constant? Oh. Yeah, we should be defining this at comp time as well. We should be making space for it at comp time. Let's move this back to this part. Let's move it down here. Procedures. Try again. Expected F32 found U size. Yeah, that's why I'm saying convert this. I'm saying as. Like convert this from a pixel to F32. Okay, maybe I need to use a different function. Is it like float from in? From memory, this is what it was. Yeah. Oh, but is it gonna want to know that I want to convert this to an F32? Hopefully. No. I need to tell what it is. Okay. Yes. Awesome. Great. Okay. This is what I wanted to do tonight, and it is now working. So yeah, we are now drawing all of these pixels individually, and so in particular, we can start to do some fancy effects with them. They don't even need to be fancy. Let's just draw a really minimal effect, which is drawing each of these pixels with a visible border, and then we'll call it. Then we'll call the stream done. But I'm very happy. I guess like 4 days ago, 5 days ago, around this time of the night, massive headache trying to deal with importing bitmap fonts. Now we've kind of just done our own stuff from scratch, and it's now working. Okay. So yeah, let us. I guess I can like move this a bit. Let's have some more fun with this. So instead of drawing this centered rect, can we draw a bordered rect? Like I did in the butterfly app. It's fine. Okay, let's just draw something similar, but increase the pixel square size a bit. So let's times this now by 1 by 1 in each case. And let's say we render this in black and then white. Okay. Okay. So yeah, this is maybe. Okay, I kind of want the border to be a bit thicker. Let's stop using magic numbers and say like pixel border thickness. Let's try 1.25. Quit. Oh, come on, quit. Yeah, and yeah, later on I'll start doing some like fancy effects where you could just like we'll make this look better. But yeah. So yeah, I think I'm gonna call it somewhat call it tonight then. Although looking at this now, I am slightly. We hadn't quite considered that the thickness of the pixels that we're iterating over is not the black border one, since we've extended that, which is why it looks we've got some weird tiling effect. Like, we can change this if we instead made say like pixel interior thickness and made this say like 0.75. And then yeah, let's change border with interior. And now let's change the order. Recompile. The colors will be flipped, but okay, at least there's not weird overlapping issues now. This looks way neater. Yeah, so let's make this black one, white. And yeah, yeah, this is what I wanted to do tonight. This is now working. There will be small things to change, but yeah, we have a from scratch QOI image decoder, and it's working. It's working in our app. So yeah, so thanks everyone who came along and joined in on the stream tonight. For anyone who is new, didn't see earlier, all of the code I do is public and on GitHub. If you go to my GitHub page, which is the same as my Twitch username, github.com/loaded, you can see all of the code that I've been using in this project. Since it's still really new, I haven't yet added a README. Don't at me. I'll do this later. But yeah, all of the code I save now and push, you'll be able to find. Okay. So what did we update again? So we updated the main.zig, and I think that was kind of it. I probably should clean up a lot of this now and delete a lot of this, but it's late. I'll do it next time. So yeah, what do we do? I can say, yeah, got a bitmap imported into game, drawing individual individual pixels. Yeah. Okay. So yeah, that's now online. So yeah, so literally like if I update this, I kind of go to render puzzle. Where is it? I scrolled past it. Yeah, the stuff I was just on my screen there. It's before it's online, so anyone watching this stream can watch it. And yeah, I record and post all of my stuff on YouTube channel as well. So like, where is it? View your channel. Yeah, all of the recordings of everything I do is here. So yeah. Okay. Yeah. Thanks everyone for watching, and yeah, hopefully you got something out of this. If not, I hope to see some more people next time. Yeah, I'm really liking Zig, especially the community. The community is very knowledgeable, very happy to help. They're really supportive. Bye bye.